Okay, let's talk about 43 through 52. 43. 1 and 2/5 is equal to what? Well, this is just like 1 plus 2/5. Okay, and what we're trying to do here is make this into one big fraction. Instead of a number in a fraction, we want to make one big fraction out of it, which will tell us how many total fifths we have. Well, what you're basically going to do here is turn your 1 into 5/5, and your 2/5 can now be added to it. Okay, so basically I'm at 5/5 plus 2/5 is 7/5. Now, if this hadn't been a 1, it would have been a little more complicated though. So there's a little trick that you can do to make this easier. Let's say it was 2 and 2/3. That's a one funny looking 3. 2 and 2/3. And I want to make that into an improper fraction. Well, 2 is the same as 6/3 plus 2/3, which should be 8/3. But we can do a little trick. You can just something that'll save you time. 2 times 3 is 6, and then add the top. Okay, so it kind of makes a little curve there. 2 times the 3 makes 6, plus the 2 makes 8. 8 over 3, and you keep your same denominator you had. All right, so let's look at one more kind of like that and just use the little trick. Let's say we had 3 and 4/5, and we wanted an improper fraction. We go 3 times 5 is 15, add the 4 makes 19/5. Okay, let's move on. Rewrite a plus b over c. What we're getting at here is that a lot of kids don't really understand what a plus b over c means. It means that we're going to take each part of the a and the b, the a plus the b, and we're going to divide it by c. So you can break it up into a divided by c plus b divided by c. Okay? That's the main point here. So if I had 5 plus x all over 3, it's important to understand that's like 5 divided by 3 plus x divided by 3. Because a lot of times things will like simplify. Like let's say this had been 6a plus 2y over 6. And I need to understand that that really can be divided in two parts. 6a over 6 plus the 2y over 6. And then these can cancel and turn into 1s. Plus 2 over 6, well, a 6 can be written as 2 times 3, and then I can cancel my 2's. 2's cancel, turn into 1s. And so it's 1 times y is y over 1 times 3 is 3. Okay, so that is simpler than that is. And it's important for you to know that you can break this up into basically dividing both parts by the denominator. All right, let's move on to rewrite 3/5 a. This is just a crucial thing to understand as you get into algebra. You need to know that that's the same as 3a over 5. See, sometimes you'll see that in a problem, and it's much more handy to know that it's 3/5 a. Okay, so they're the same thing. So what if it had been 7/8 b? Well, that's the same as 7b over 8. Sometimes that'll be a handier thing to substitute. Okay, or maybe it comes in as 5 n over 7. That's the same as 5/7 n. All right? Okay, let's move on. 1 over n. This is a fraction in a fraction at its simplest form. And basically, when you put 1 over something, you are doing the reciprocal of it. Like, say I had a simple number like 8. And if I do 1 over 8, I have made it into 1/8. If I put 1 over it, I basically flip it over. 8 and 1/8 are flipped over, right? They're reciprocals. So if I had 2/3 and I take 1 over 2/3, I am doing the reciprocal of 2/3. So my answer would be flip it over, 3 over 2. Okay. There's a long explanation for this, which is basically that this is really the same as 1 divided by 2/3, and that's the same as 1 times flip it over, 3 over 2, and 1 times 3 over 2 is 3 over 2. That's why it flips over. Okay, but basically when you see a 1 over something, whatever you put the 1 over, flip it. Do the reciprocal of it. Okay, so if this had been 1 over 5, then just look at what's down here, and 1/5. Now 1 over that means flip it over. There's 5. Okay, or what if it, even more complicated, had been 1/4, and I did 1 over that, and then I did 1 over that. Okay, 1 over 1/4. Well, you start by looking down at the bottom and seeing what that is, and saying, all right, if this is 1/4, as soon as I did 1 over 1/4, that's the same as 4. And as soon as I do 1 over that, it's 1 over 4. So my answer would be 1/4 on that one. Okay? All right, that gets a little complicated, but it's really pretty simple at its essence. When you have 1 over something, just take what's on the bottom and flip it over. So this answer would be 1 over n. There's 1 over n on the bottom, and I took 1 over that, so I flip it. And the answer would be n over 1, or just n. All right, moving on. 8/7. Rewrite it as a mixed number. Well, right now it is an improper fraction, okay? And the way I like to think of these is that this is really made up of 8/7 is really 7/7 plus 1/7. And I broke it into a number that would work nice here, okay? Something that would simplify down to a whole number plus whatever's left, okay? So 7/7 is really 1, and 1/7 comes down. So it's 1 plus the 1/7 is 1 and 1/7. All right, let's say it had been 9 over 4. Well, that could simplify into something that would make a whole number, like 8 over 4 plus 1 over 4. That would be 9 over 4, right? And 8 over 4 makes a whole number. That's 2. So 2 and 1/4 would be the answer for 9/4. Would be 2 and 1/4. Okay? So try to break it up into a fraction like this, where you'll have a whole number for the first part, and then whatever's left over as your second part. Okay, moving on. 20 over 35 reduces to, well, this is a simple reduce question. You can reduce this in a lot of ways, but the way I like to reduce things is to use canceling and try to figure out what I could rewrite or substitute in for each number. If I'm going to take the 20 and I'm going to substitute it in something for the 20 could be written as 5 times 4. And the 35 could be written as 5 times 7. And why did I do it that way? Because then I can see that my 5's can cancel. Because 5 divided by 5 is really 1. So I can change this to 1 over 1. And that means that the answer would be 1 times 4 is 4, over 1 times 7 is 7. 4/7. Say I had another one to reduce, and it was like 8 over 20. Let's just do 8 over 20. When you think of what goes into both of these, 4 does. And so I'd say 4 times what on the top and 4 times what on the bottom. 4 times 2 is 8, and 4 times 5 is 20. And so then my 4's can cancel. They turn into 1s, and I have 2 over 5 as my answer. Okay? So that's my best advice on how to reduce those. Number 49, A times B over C. Well, fractions really work best with other fractions, and this one's a fraction and this one's not. So let's make the A into a fraction. It's really A over 1 times B over C. And then if you know how to multiply fractions, this will be easy. A times B is AB, over 1 times C is C. So there's my answer, AB over C. If this had been M times N over Q, again, you look at it and say, well, fractions get along better with other fractions. So let's say it's M over 1 times N over Q, and I'd have Mn over q. All right? Anytime you have a whole number like this working with a fraction, just put it over 1. And you can have a fraction work with a fraction, which is much easier. All right, moving on. AB over CD, A over B, sorry, over C over D is the same as A over B divided by, that's what a fraction bar means, divided by C over D. And that means A over B times, and I flip it, D over C. Okay, because you can change a divide into a multiply if you change it to its reciprocal here. And so now I've got AD over BC. AD over BC is my final answer. Okay, so yeah, I could have like somehow memorized that and that go on the top and that go on the bottom. Don't do that. That will just get you confused later. Think of this as a big divide problem, and you can write it out that way, and then it should be easy. So if I had 2/3 divided by 3/4, that really means 2/3 divided by 3/4 this way. See? And then that's really 2/3 times 4/3, because I switched this from divide to times and that to 3/4 to 4/3. And then my final answer is just a multiply fractions problem, which comes down to 8 over 9. Okay, so there's another couple examples there. This one, remember how I said that fractions get along better with other fractions? Well, basically, I've got a whole number on top, and I've got a fraction on the bottom. So I'm going to rewrite that as A over 1 over B over C. And then it's just like the one we just did above, where you just say A over 1, and instead of saying a fraction bar, I'm going to say divided by B over C. Okay, all I did is rewrite it, and now I'm going to rewrite it again. A over 1 times, flip this over, C over B, and then my final answer is AC over B. Okay, so remember, if you've got a whole number, like just a variable like A, over a fraction like B over C, you've got to get fractions and fractions. So you make your whole number into a fraction, and then think of your divide as or your fraction bar as a big divide sign. Okay, moving on. Remember how I said whole number, make it into a fraction? This would be 7 over 1 times the 2/5. And now it's just a fraction and a fraction, and it's a piece of cake if you know how to multiply fractions. 7 times 2 is 14. Over 5 times 1 is 5. 14/5. Now some people look at that and say, well, you've got to keep going, don't you? Not necessarily. A lot of times that's a good enough answer. It may be an improper fraction, but it works really well in a lot of algebra problems. If I had 14/5 in my equation like this, let's make that an x. You can see better that would be like a slope, and that's a good slope. It tells me how much to rise and how much to run, and so I don't need to fix that. If you really want to, you can write the 14/5 as, well, I could say that's 10/5 plus 4/5. That would be the same as 14/5, right? And then that would be really a 2, so 2 and 4/5. All right. That's all we got for now. See you on the next clip.